Next, we have an interesting collection of leaders in AI, including device maker DJI's Romeo Durscher, solutions provider AAEON's David Hung, and our very own Davis Chen, Kneron's VP of Engineering. The panel will be moderated by Stephen Nellis, who covers technology for Reuters. So let's learn about what they have to say about embedding AI on devices.
Hi, I'm Stephen Nellis, a reporter with Reuters, the news organization, where I cover the semiconductor space. And I'm here with a great panel of guests today to talk about artificial intelligence done on the device. And so if we could, I'd like to have our panelists, David, Romeo, and Davis, all kind of do a quick introduction of themselves, just so everybody knows where everybody's coming from and who everybody's with. So maybe, Davis, it'd be good to start with you.
Oh, sure. Good morning, everybody. I'm Davis Chen. I'm the VP of Engineering from Kneron, and I also look after the product management group.
Great. And then Romeo?
All right. Thank you very much. This is very exciting. My name is Romeo Durscher. I'm the Senior Director of Public Safety Integration at DJI, and we manufacture consumer as well as commercial drones. Drones have made a big impact, especially in public safety. Now with the wildfires here in California, once again, drones are coming in as a tool and a force multiplier. 3 years ago, we deployed to our first wildfire event in Redding, California, the car fire, and there we integrated AI module to help us in our work.
And David.
Hi, this is David Hong. I'm from AAEON Technology in Taipei. And the AAEON is the leading industrial computer manufacturer. And in the last few years, we are focusing to developing AI to our computers and our applications in the AI age and AI IoT related field.
Excellent. And so before I kick it off with questions, I just want to say thank you to all of our panelists from joining from a variety of time zones here. I know it's different times all over the world, so we really appreciate everybody being able to get here. I guess the first question that would be best, and maybe this would be good to start off with for Davis, is let's try to locate what we mean when we say AI on device. So if we kind of make a grid with 4 different quadrants on it and think about, inference and training, and then think about sort of a spectrum from big powerful chips that consume and the many watts of power in the data center, all the way down to devices that have very, very strict battery requirements because they've got to compete with a lot of other things in the system. What do we mean when we talk about AI on the device, and what's Kneron kind of tried to solve as an issue there?
Sure. Yeah, that's a very good question. So AI. So what we're trying to focus on is AI model that has been trained on the cloud, but the already trained model running on the edge instead of the cloud to give users a little bit more the security, as well as an AI device that are running mostly on battery or purely on battery. So we're focusing on the very ultra low power aspect or the usage case of deploying AIs. So that imagine a device on the edge that are not connected to the power outlet, but on the battery. It could be on the DJI drone. It could be on an AAEON device that are way out in the field in the remote areas. Basically leveraging the AI model to solve a certain problems, living off of a battery, that will last 3 to 6 months, or in some cases up to 12 months. So the key is how do we take a already trained model from the cloud and deploy on the edge, converting from floating point to integers and be able to run on a very power efficient, ultra low power. So what we're trying to hit is this tops per watt. And that's where Kneron is focusing on, and that's where I think the usage model and the application gets very interesting. That will open up a lot of possibilities where computing or AI cannot go today. I think in the future with Kneron's chip, we can actually open up that possibility and enable those products and applications.
So that's a really good recap. David or Romeo, what are some, that's a very good general explanation, but I'm wondering if either of you could tell us about, some actual applications that you're looking at, thinking about, some real specific use cases that you're looking at or thinking about with regard to doing AI on device at the edge.
David, do you want to go first?
Well, you are from the DJI, and actually my example here is about the drone. Well, if you want me to take it, okay. And I think I would like to list a few points about the AI, what we need in the industrial AI. I think the first thing is has adequate AI power, because in my industry, sometimes we only using AI for a single task, like a visual to recognize some certain objects. And the second thing is the size has to be small, because sometimes my computer board is only the size of a palm or even the size of a credit card. And the last two things is the low power and flexible. So using Kneron's solution, it is only 0.5 watts, just like what David said. And another benefit of low power is we don't need any cooler. We don't need any heatsink on top of it. So we can make a whole application fit into a small enclosure, such as using on the drones or in a mobile robotic in the field. I think that's what our application is. Yep.
Yes, thank you, David. The drone is a data collection device. It's a camera that can operate in 3D space. And what we're looking for are data points. And oftentimes, as a drone operator or a visual observer or somebody who looks at the footage in real time, a lot of information are coming at them. So using a proper AI model, we can really help an operation. And I'll give you a couple of good examples. As I mentioned earlier, when we deployed to Reading to the car fire in 2018, we had developed an AI model that helps us locate burnt or damaged buildings, burnt or damaged vehicles, so that when we fly over a community, we immediately get actionable data. We get a count of how many homes have damaged or destroyed, how many vehicles are destroyed, so we can time. Another one that is of very big interest, again, in public safety is, for example, search and rescue. With the help of an AI model, we can easier detect signs of a human being. Maybe there was an accident and a person lies under a tree and only the feet stick out. And so it's easy, for an operator to miss that, but the AI model can then help with the detection of those feet or a piece of clothing or whatever the case may be. And then in inspection, especially like power line inspection, where we're looking for corrosion and items that are broken. And so training that model to look for those items and highlighting them really brings a huge ROI to the operation, because we're saving time and we're mitigating the risk through AI models.
And so one of the things that David brought up was having sufficient sort of AI power. And one thing I'm wondering if either David or Romeo could talk about would be what do we mean by that? And how much training has to go in on the front end in order to get those really good results at the edge? And how much does the performance of the chip at the edge play into that?
This is a very interesting topic, and my focus mainly is on the public safety side and our technology. When I first learned about what it takes to build an AI model, I was amazed at how labor intensive it can be. However, over the last couple of years, those algorithms have become so much more powerful that it doesn't take as long to create that initial model, and then it continues to learn thanks to the capabilities that we now have in the technology sector. And so it becomes much more interesting. Before, when you had to use 10,000 images and categorize each image, that was so labor intensive. And some of the smaller models that we've helped create, they've used 50 images and maybe 2 minutes of video to already bring strong results. And I think that's really what makes this so much more applicable and interesting.
Speak of the AI's model and the size. I think for my portion that we are focusing on the light AI models, which like a YOLO type and recognize 100 pieces of object at a time, and that is enough for our customers to using it in the field applications such as drones or the bending machines to make sure each items are in the right angles.
Yeah. Another thing that came up was flexibility of these chips. And I wanted to go back to Davis and ask a little bit about software. So one thing that's always important when you're designing silicon, right, is the stack and what's gonna run on top of it. There's been a lot of change and evolution in the software space. And so, Davis, I'm wondering if you could talk a little bit about, you're designing a chip. It takes a certain amount of time to get to tape out on a chip, but that amount of time is not necessarily sort of the same kind of time frame or time scale as software can change in this space. So I'm wondering if you could talk about, what kinds of software and frameworks and things are you trying to aim for compatibility for? And, how do you balance that when you're trying to create silicon where, that process can sometimes be on a much longer time scale than the evolution of software and in a space like artificial intelligence. So what kind of software are you trying to work with, and how have you tried to keep that current with what's going on in the field?
Sure. So yeah, as always in the technology sector, the key is to be able to adapt, right, and then also be able to adapt very quickly. And that was a very good question. That as we develop a silicon, how do we make the best use out of the silicon in terms of what are the AI models, AI framework that we can support. And we have made a lot of advances in providing many converters. So we'll be converting from all the AI models that are out there, sometimes utilizing the open source software, sometimes utilizing our own proprietary software to convert all the models into ONNX, the Open Neural Network Exchange framework. And once it is converted to ONNX, then we go through prunings and compilings and all the compressions to kind of get the models down to the size of at least 50 megabyte or less. And that's where I think it runs best, on our chips. And like the question states, we have to adapt, and we don't get to roll out a silicon, every day. So another thing that we do is in the pre and post processings, where we enable, for example, running a CV algorithm, as a filter, as like a first stage and second stage, so that if the CV algorithm, as a first stage, see something that are of interest and filter out, things that are of, not as important, and that's where we can optimize. And basically, you don't really need to wake up the MPUs to do the work if the CV already see that, or this is unrelated image, or this is an object not of an interest. So that's how we kind of combat and adapt to change. And in the pre and post processing, there's a lot of things, a lot of creative ideas. Some of them are to save power. Some of them are to utilize the algorithm better. Some of them, as I mentioned, is just to basically decide when to kick off the MPU or not. In terms of having two layers, and that give you a little bit more granularities in terms of software designs.
Great. And I'm wondering, David or Romeo, if you guys could talk to that issue too. I mean, you know, you guys are in an interesting position where on the one hand, you've got system decisions to make, but on the other hand, you know, you've got customers who are, you're either going to work with them to design software, or they're going to bring software. So how are you thinking about these issues in terms of, you know, trying to sort of, you know, hardware designs are similar in as much as they take a while to bake, and then they tend to stay baked for a while, regardless of how fast the software moves. How are you guys thinking about this issue when you decide, you know, your bill of materials and kind of what you want to put into systems? Are you looking for things that will give you that flexibility in case some hot new framework comes along, you know, a year and a half from now? And maybe David, it'd be good to start with you, because I know for some of these industrial things, the amount of time they can be expected to be in the field can be pretty long compared to consumer or even sort of you know, even other enterprise devices.
For the software side, actually we are relying on Kneron's SDK, and actually our customers can leverage their SDK to make more of their models. Not just that, they also using the models in the open source, and then they modify the open source things into what they need. So I think this is one of the great technological software improvement, because people can using the open resources and then convert it into their applications to fit in what they need. So I think most of our customers actually using Kneron's tool chain to convert the tools into the Kneron's solution. Yeah.
And for us, we also have our own SDK for our drones, and a lot of solutions come through the SDK. Obviously, we have a little bit more flexibility as well in regards to how we want to apply an AI model. In the future, I think the AI will reside on the drone itself and potentially even have connectivity from the drone. But right now, we want to keep our drones as compact as possible. And so what we're seeing is that oftentimes the drone footage is being streamed potentially onto a server, and then at that location, you run the AI algorithm on top of the data stream that comes in. Obviously, there's a little bit of a delay, but that's okay, because it's not very significant, and you can always figure out, like if we're doing a search and rescue operation and the AI model picks something up, but it was not live on the drone, it was in the back end on the streamed footage, there may be a few seconds delay, but we know where that location was because of the telemetry information that's part of the data. So that delay doesn't really make a difference. I'm really looking forward to more of these applications being on top or inside that vehicle, and not having to rely potentially on a live stream, you know, solution.
Yeah, I'm wondering if you could talk a little more about that, because, you know, as we're talking here, we're mostly talking about the world of a trained model that's been trained somewhere else, presumably in a data center, maybe on a workstation, depending on the scenario, and then essentially pushing that down, you know, to the edge. But one of the most fascinating things about AI is its ability to self-improve based on the feedback that it receives at the inference stage. So what does the future look like there in terms of, you know, starting to push back some of that data that you gather in inference, right? And to eventually refine the model. Because when AI goes from, you know, from interesting to potentially really, really, really interesting is when you start to get that feedback loop of every bit of data that's coming in, especially with network devices. For example, you know, is there a world where you might be looking at something from 2 or 3 different angles with 2 or 3 different drone devices, right? And then you can say, aha, we found a snag in the model where there was something we consistently weren't recognizing that we wanted to recognize, but now that we've seen it from 2 or 3 angles, we can push that back into the core model. So What's the future hold there? Where are we on that at this moment?
I think we're already seeing some of that happening, and it's extremely fascinating. I'll give you a good example. Let's say our drones, they have a GPS inside, and so they know where in 3D space they are. If you initiate a return to home, it knows where it took off, and it will autonomously fly back and land itself. Now, if we do an operation indoors where we have a no GPS environment, GPS denied environment, we can't utilize that feature. So drones have a variety of different sensors on them to kind of, scan their environment, and based on that, try to avoid obstacles. Now, if we're flying in an indoor operation, let's say it's a hazardous material one, it's a big warehouse, we don't want to send in individuals, we send in the drone first, and we fly this drone into the warehouse. And with all the sensors, it starts to already build kind of like a rudimentary model of the environment it is in. And through that, then know how to fly back to not, bump into things or not find the exit out. And I think we're starting to see all of that now happening on the drone, and the drone learning its environment and then using that data to navigate itself back to where it came from.
That's interesting. Does it have any, can you eventually, so what do you do with that data once you've navigated back to where it came from? Like, at what point can it get pushed back up into a, or does it ever get pushed back into a model, or do you just kind of keep that in cache on the device as a localized, kind of indicator of a localized environment that you've mapped?
Both, actually. So you have the ability to live create that model at the operator stage, because that data is all being transmitted, and you can already create a rudimentary model. It keeps it also on the drone, so that if you have to go back in there, it already has that model that it created in its brain, in essence, to help navigate through. So the autonomous factor definitely will continue to be built and utilized more and more, especially in indoor environments. Right now, the regulatory environment for flying autonomous outdoors is a little bit different, as it still needs a pilot in control that can jump in and take over if need be. But again, I think with the AI component in the future, this will become more and more safe to do autonomously, because the drone in essence will recognize its environment, its potential threats that could be in the environment, like birds or crewed aircrafts. So very, very fascinating outlook into the future.
Yeah. And, David, I wanted to kick that over to you a little bit. One of the things that was mentioned was sort of a hazardous materials indoor situation. You can certainly see a lot of scenarios in the industrial world where it might be good to start sort of building a local model there. Is there anything that you guys are seeing on that front, or thinking about for the future, about like, hey, maybe these devices need to build and refine their models in the field?
Actually, in my field, I can see that people are using AI to handle some lousy jobs, such as using the human's eyes to do the inspection, or in one of our vehicle applications, that application or that solution using AI's camera to count how many children get on the school bus. And if there is anyone missing, it will help the driver to send a signal or send a call to the home or to the school to inform them, hey, I didn't have these kids on the bus at this moment. And by using the camera, it also monitor the driver's eyes to make sure the driver is in the good status to driving to bring them home or to bring them to the school. So I think AI will be our a good assistant in the future, and it will supporting humans to do their job to make it more precisely and to make things more safely.
Interesting. So another thing I want to touch on is cost, because that determines a lot. One of the reasons we're even able to talk about all these interesting things we're doing with cameras is the humongous decline in digital camera sensors over the course of the past 20 years, where the quality and size you can get for a very small price is just incredible. I still kind of remember the days when there was still talk about digital versus film or video, etc. So those days are long gone, and that cost curve has come way down. Davis, where are we on the cost curve for, maybe the way to think about it is if we look at it at a given tera ops per watt, where are we on the cost curve right now, and where is that headed, and how is it going to stack up to things we're more used to talking about, like mobile CPU, right? Like, where are we now? Are we where mobile CPU was in terms of cost of processing unit in like the mid 2000s? And then what's that curve going to look like as more and more companies get into this sort of vigorous competition for AI at the edge?
Oh, yeah, that's a very interesting question. So the technology have advanced, tremendously. Today you're looking at a, ARM-based single board computer that are in the price range of, say, $30. That can rival your Windows PC, that were running full Windows just a few years back. In terms of, AI application at the edge, we're looking at building a device also, at the, potentially $30 range, as a whole device. And imagine that you're running this device, 6 to 12 months. It's almost like a throwaway, right? People pay for video streaming services, $10 per month. And if this is some device that are, $30, $50 price range, where it operates in the field, like both gentlemen are saying, from DJI and AAEON, in a mission critical environment, where safety of the operator is of a prime concern, or of a very tedious and lousy job. And imagine, $30 or $50, you get yourself a device that can be, throwaway, if it operates 6 to 12 months. And especially when it operates in an area that are, that could be very tedious for humans to perform, or it could be very dangerous for humans to perform. It could be a very harsh environment. It could even be a dangerous condition where, they are dangerous gas. And it's just tremendous capability where we are growing the outreach, right? One thing that we're growing the outreach was the battery power. As you can operate off of battery, you open up possibilities. The other thing was, streaming, where you are basically limited by the 4G or 5G network, where you're constantly streaming back the video image that are collected. Since we're doing the AI on the edge, we don't need to stream back all the images and the video, so that further open up the outreach of where you can deploy this device, right? And where we expand this further, into these dangerous areas, dangerous environment for human to operate, and maybe more into AAEON's application, is you really get into this very, very niche or very remote area, where you put like 2 AA battery, and it should operate for 6 to 12 months, and then in the end, maybe before it ultimately shuts down, it had gathered enough data, right? And these data are not in the image or video format, so it's much smaller in size, where you could finally send back all the data through an NB-IoT. So yeah, so going back to address the question, the costs have really come way down to the point that it's almost like a disposable. It's like in the old days where you have very expensive cameras, and then you have disposable camera, and now everybody is using a digital camera. That the fact of having a camera or bringing a camera is it's not in the mind, because you will always have your smartphone with you, and everybody has a camera. In fact, everybody has multiple camera, and it's always with you. So we sort of go from an expensive camera to a disposable camera, to not even have to think about camera. Camera is by default almost like a basic human capability. And I think in terms of AI or having AI at the edge, or having multiple AI, helping you with, making your life more convenient or making our world more safe, it will become so default that it will be everywhere. That's my opinion.
Yeah. Well, and one quick follow-up on that, and then I want to be mindful of our time. We're getting close, and I do want to get a little bit more from DJI and AAEON. But quick follow-up on that, with the power you're at right now, and I think if I remember, it was half a watt. I might have had that wrong, but with the power you're at right now, what does the curve look like in terms of getting that down? And what's the timeline for getting to things like a coin cell battery, like we see some of these Bluetooth low energy devices using right now? And then way in the future, is there any possibility of using things like, various wireless power transmission technologies to do this kind of stuff, where you could potentially power things over, maybe not a huge outdoor environment, but even an indoor environment that's fairly closed in without having to have any direct battery attached. So what's the power curve look like for getting to, coin cell battery and even crazy science fiction wireless power transmission to power this kind of stuff?
So question.
That one would be for you,
okay,
Davis.
sure.
And then I want to ask DJI and AAEON what they would do with such crazy sci-fi stuff in the future. But what's it look like on the power curve?
Sure. So yeah, the power have come way down. And when we design the silicon, when we talk about the 1.5 tops, or when we talk about 0.5 tops, what's important to remember is also the tops per watt. And and we're hitting 0.5 tops per watt, or sometimes we're hitting 1.5 tops per watt. And these are the ceiling capabilities. And like we talked about it earlier with the software, having pre-post processing. The other interesting things with the software is that we get to regulate the clock. We get to regulate how fast the chip is running. So basically, essentially, we get to regulate how many tops the chip should be running at, and that then dictate on how many watts it will consume. So having a chip that will operate at the 1.5 tops per watt doesn't mean that you always have to run it that fast, or that at that power level. I could actually tune it way down, for a specific application running only 0.3 tops, and in that cases I'll be consuming very, very little wattage. And if coin cell is a requirement, and maybe that will be the way to go. And that basically can be dictated by the software. So I would imagine that when deploying these devices out in the field or on a drone, it could dynamically adjust, right? In some cases, the CV algorithm can determine that, well, for this cases, I'm going to load this heavier model, and I probably need to run my MPU at the 70% capability, consuming 70% of the power. Or this is a scenario that I'm going to load this very tiny little model, and I'm going to run the CPU at 20% and consume only 20% of the powers. And so you can see that how much power or how much capability it can be dynamically arranged, and that will save a lot of powers.
Great. And then David and Romeo, just use your imaginations. What kind of pie in the sky stuff would you be interested in doing if these things were, of negligible cost and negligible power footprint?
I think from a drone perspective, I would say scale. For example, with the California wildfires, if we had thousands of these, medium-sized drones that had the capabilities to scoop up water and just, thanks to AI, fly information, keep like a constant supply that just goes from a lake to wherever the fire line is and just drops and goes back. Or swarm technology, swarming for search and rescue. Multiple drones that help cover certain areas where it may be too dangerous for boots on the ground to go to, like a cliff, but with 5, 10, 15 drones covering that area and all flying information, following the landscape. I think those are amazing applications that will not only save lives, but help our first responders to stay more safe.
And David?
At my side, most of my applications, they are using fixed power. So for the battery side, for battery, it's most for a backup purpose to make sure the whole unit can still running for like 2 or even 8 hours without any power attached. So that if it is using at like a life-saving or some critical environment applications, it can still sustain for more hours. And as I mentioned before, in my field, we want the AI application to be as small as possible. So if if we can using a very low power AI solution, that means at the same size of battery, I can make my application to live longer. So yeah, we need a low power AI solution for this.
Got it. Great. Well, I think we've about hit our half-hour mark here. So I just want to thank everybody again for taking the time to do this and talk about AI on the edge. Fantastic conversation here, and I hope we can all talk again soon.
Well, thank you, Stephen. It's been a pleasure.
Thank you.
Thank you, Romeo. Thank you, David.
Thank you, Davis and David.
Thank
Stephen.
you, everyone.